Yes, I hope everyone is able to see my screen. And we will start with the tool, electric. So I hope everyone has started doing your digital experiments, especially the circuit part. Any doubts regarding that? Any doubt up till in doing the schematic? Because today we will be starting with the layout part, that's why. So we have an inverter and we have simulated this circuit also, and we have to start with the layout. Okay, so if there is no doubt in the schematic or simulation part, we will be starting with the layout. If you have any doubts, you can ask now. Yes. Yes, shall we start with the layout? Okay then. Yes, Farhan, if possible, you just do the YouTube streaming and send the link to the same, okay? So we can share it. Yeah. So now to start with the layout, I hope everyone knows how to create the cell for the layout. I will delete this and I will create it once again. So this is schematic, inverter schematic, and I am creating a new cell with the layout, and the names should be same which I had given for the schematic part. Okay, and the view type is layout. Okay, you see now with the inverter you have two types. One is schematic, and the corresponding to those schematic you have a schematic components, and the other is layout. Corresponding to this we have a layout components. Okay, so once you available this window to start with, yeah, so first you have to select the MOS devices. So this is NMOS, you can see at the bottom, and I'm keeping at the lower end, and PMOS, I'm keeping it at the upper end. Okay, PMOS, well, in the schematic, this is 20 by 2 and this is 10 by 2. See, in the schematic, the size of the PMOS is 20 by 2. You can check the property here. It is 20 by 2, and for the NMOS, it is 10 by 2. Okay, 10 by 2, what we have done, the same length and width has to be taken for the PMOS device and NMOS device. So this is PMOS device. So I'm changing the width of this to 20, and the length will be as it is 2. Okay, and this length will be 10. Okay, so this is 10 and this is 20. Okay, so now see, this is a simple bare transistor. It doesn't have any contacts on the either side. Okay, so to have that you need to have an P active contact. You see here, P active contact corresponding to the PMOS device. Fine. And N active contact corresponding to the NMOS device. Is that clear? P active contact for the PMOS device and N active contact for the NMOS device. But see here, the connection is not done here. Okay. So the size of this will also, I will take it as X direction to be 20. Okay. So this X direction size also 20 corresponding to the width of my MOS transistor. Okay. So now as you see, it is not been connected as of now. Okay. So if you merge this way, then also it is not considered to be connected. Note that. Okay. So you have to connect it physically until unless you make a proper circuit or MOS device. Okay, I have just aligned it properly. Okay, the active device, I mean PMOS and the P active contact. Okay, and you look at here to make the connection, the procedure is same like what you did in the case of schematic. Okay, what is the procedure? Left click at the starting point, right click at the end point. Understood? Left click at the starting point, right click at the end point. Okay, so now this makes it to be completely connected. Okay, otherwise it is unconnected. Understood? And now you can align it so that you can make it a proper transistor. And when I am aligning it, you see you will get a DRC rule there itself only. See here, P active spacing is 4.5. I am still moving it. So now I am getting it as an error. Okay. Now I am getting it as an error. So here I am not getting it as an error. So I will reduce the grid size still to make a minute movement. You see here, still there is no error. You can check at the DRC rule, which is actively visible on the connections when you are making. P active spacing is 3. So now if I move it further, it will show the error. Okay. So it is 2.5 it seems. The minimum distance should be 3 micrometer it seems. That's why I will just take it back by one step so that now the P active spacing is 3 unit. Okay. So the same you have to do it for the to the other end. Select this, continuously hold it and keep moving it. Continuously hold and keep moving it and look at the DRC rule. Now it is error. Okay. So I have hold this continuously and then I am making a movement. So now you have obtained with the PMOS transistor with its active contact. Okay. So you will not have an active contacts connected like you get in the case of cadence tool. Understood the point? So here the every step has been done manually, has to be done manually. Okay. So similarly for the NMOS, so this width X unit, I will change it to 10 corresponding to the size of NMOS transistor. Similarly, the other one 10 for the NMOS transistor. I will align it and then I will move it. You can look at here. You are getting a DRC rules displayed there itself only. Okay. Okay, sorry, I have not made any connection as of now. Okay, that's why it will show the error. See, if I move it, it will show error here itself only. Minimum spacing is 3, it seems. Okay. So that's why I need to make the connection first. How to make the connection? Left mouse click at the starting point, right mouse click at the end point. Similarly here, left mouse click at the starting point, right mouse click at the end point, like you did it in the case of schematic wire connection. Now you see you have a DRC rule coming over there, and you have a minimum spacing available there itself only. Okay. See here, this is for the other. So now this is your complete NMOS and PMOS. Okay. So since they are horizontally oriented, I will make it vertical orientation by selecting that entire MOS, edit, rotate 90-degree clockwise. Okay. How do I do that? Select entire the mouse, means left click continuously to select the entire area of mouse device. Once it is selected, go to edit, rotate and clockwise. Okay. So now you see, so here I will make a poly routing. Left click at the starting point and right click at the end point. So I will select this and move it continuously to the aligned area. You can see here. Okay. This I will just disconnect it because I did it only for the alignment purpose. Otherwise, it will not make a connection up till you make left click here and right click here. Understood this procedure? See. Control Z to make an undo. Okay. So this is your MOS device. You can move this, I think, shift. Shift for multiple selection. M for movement. Sorry, M is for measurement, I think. Shift for multiple. Okay, this is entirely merged. I will take it bit distance. Okay. Clear? Is that clear with everyone? Yes. Any doubt up till here? So this is how you place the NMOS device and PMOS device aligned properly in your layout editor. Okay. So now further, to make a VDD and VSS line, we have a metal routing. We will select a metal layer, which is blue color, if you see light blue color. And to do the routing, same procedure. Okay. You have to create left click at the starting point. Sorry. Properties, I will select a pin first. I will place it here. I will select a pin first. Note that I will select a pin first, and then I will select a metal routing, and left click mouse at the starting point, right click mouse at the end point. This is my power routing. Okay. So this I will change the width of this to some 4 or 5. So to make look bigger. Okay, and you see that pin is cancel. See, there is a pin over here. Okay, and it is this pin what you are supposed to export. Export this as a VDD. Okay, selecting a power characteristics. Okay, this is VDD. Similarly, for the VSS, select pin, place it here first, select metal routing, left click at the starting point and right click at the end point. Okay, I'll change this property to 5, width to look bigger, and you have I have selected, I have pressed control and keep selecting that until I get that pin which I have placed. Okay, so select that pin, export, create export. It is VSS line. Okay, so this is my power lines. Okay, and this is my polyactive contact to make an input. Okay, polyactive contact to make an input. And to make this connection, left click at the starting point, right click at the end point. Okay, don't start from here, otherwise it will take this as the default width. It will take this as the default width if you start from here. Okay, so don't start from here, start from the minimum width. Okay, so this is your poly routing and having an polyactive contact. This is your input. Select this and again export, create export. This is input, select it as V in. So this is your V in pin. Okay. So similarly for drain to drain connection and this active contacts, you use metal routing. So select the path starting point, left click at the starting point and right click at the end point, left click at the starting point and right click at the end point. You see you have a pin over here. I will export this pin itself as V out. Export characteristics as output. Okay, this is my output. I hope everyone is able to see this. To change the property, Control I. Okay, so the text size I will give it as 5 so that you can see it. Okay, see if this layer is not visible, you can, that is not selected, you can keep clicking by selecting a control button in your keypad. Okay, control and keep selecting until that particular character or the layer is selected. To check the properties, Control I. So this I will change it to 5. Control I, change it to 5. Similarly, Control I, change it to 5. Okay, this is my VDD, VSS, V in and V out. So these two are drain terminal which are connected to the output pin, and this is the source terminal connected to the VDD. So to do the connection, left click at the starting point, right click at the end point. Similarly here, left click at the starting point, right click at the end point. Okay, so this is your inverter circuit with a simple input and output, what you see over here. 3 terminal device, I mean to say. Of course, you need to add the 4th terminal over here. Okay, and you see this is NMOS and this is PMOS. Whereas NMOS is fabricated in which area? You have here different wells. Tell me. NMOS is fabricated in P well. That's why you select a P well to place it near the NMOS device. Okay, to make it as a 4th terminal. Similarly, for the PMOS device, PMOS is fabricated inside the N well. You select the N well, place it near to the PMOS device. Okay. And again, connection. Left click at the starting point, right click at the end point. Left click, right click. You see? And this you can move it up till you just overlap it. Okay. So is this clear? So this completes all the four terminal MOS device, PMOS device as well as NMOS device. Just a minute. Yes, any doubt up till here? So this completes the layout of inverter circuit. Any doubt up till here before I continue for the simulation? Yes. Just a moment. Yes, everyone is able to see the screen? Yes. If there is no doubt, I will just continue for the simulation. You see, this is the command interrupt window. Tool DRC check hierarchy. 3 errors are there. Again, to check those errors, layout inverter. Minimum width means it is not completely abutted. There is okay, this I will just keep it. Okay. Otherwise, I'll change this Y size to 20 corresponding to that most size. Okay. And this also to 10 corresponding to the most size. Save, and once again tool DRC check hierarchy. Yeah, now there is no errors. I will delete the previous one. You see, this is no errors when I did it once again. Okay. So this is my inverter circuit. I will run it once again. Tool DRC check hierarchy. See, you have 0 errors and 0 warnings. Okay. And again, for here also, to do the simulation, you have to set spice model for this. Okay. To set the spice model, first select this device. This is P transistor. This has to be selected. Then go to tools, simulation spice, set spice model. Okay. So you have to select that and you have to rename it as PMOS. If it is not selecting, press Control key continuously and highlight it. Now it is selected. Control I to check the properties. name it as PMOS in capital, click OK. This is PMOS. This is how you setting up the model for this active device. This is NMOS transistor. If you have doubt, double click on this, you see this is NMOS transistor. Okay, it is already been selected. Go to tools, write spice deck. Sorry. Go to tools, set spice model. Okay, so select control and keep selecting on that. So it is selected now. Control I, NMOS in capital, and this is how you set spice model for the NMOS. Okay, and again to write the code, you have to go to miscellaneous spice code, miscellaneous spice code, select over here, the text will be selected. Okay, so select it again, control I to select the properties, select the multi-line option. You have to write the code for this. Dot include C electric backslash C5 underscore models dot text. Okay, VDD space VDD to 0 DC 5 volts, VSS 0 DC 0 volts, VIN 0 pulse 050 1 nano 1 nano 20 nano is the on period, 40 nano is the total time period. And the analysis what I'm doing is dot tran from 0 to 40 means for 2 cycle I will take it as some 80 nano. Okay, so this is how I write the spice code model. Okay, I'll change control I to check the properties. So text size I will make it 3, somewhat bigger, so you can see to it, right? So this is the spice code, and I hope no need to explain these instructions what is being written in the spice code. It is already been explained. Okay, so once again check and save. Go to tools, check hierarchy to find the DRC error, and then spice simulation, write spice deck, inverter display, save. Yes, this is the layout. You see all the layers now. Earlier it was only W and L. So now it is the along with L and W, you have the other dimensions also. Okay, which is being explained. And I will check the waveforms V in and V out. Well, this is my output. This is my input. Okay, the output is not going up till 5 volts. I'll just check with my schematic bit. VDD 0 DC 0. Yes. What is it? No ground. This itself is the ground, right? Which has been exported. So this is anyhow connected over here. This is my output. V in is correct, but V out is somewhat different at this point. It is showing that there is no ground connection, it seems. No ground connection for N transistor in cell inverter layout. VSS 0 DC 0. That is what ground is. Right, I'll just check with the if this is same up till 5 volts you will get VSS. I'll just do the DC analysis dot DC V in from 0 to 5 volts in terms of 1 milli. Yeah. Okay. Output is not going up till 5 volts actually. 0 to 5. Yeah, all these terminals are connected. So all these terminals are connected. Uh, 0 DC 5. Right pin. This is drain terminal. So it is not driving up till VDD. I'll just check with this once. Okay. But this is the procedure for doing the layout actually. Okay. So any doubt in this up till here? So I'll just check with what is the error with that later on. Okay. Is it with the code or anything? Well, this is just a procedure for doing the layout for the schematic what you have done. Okay. So any doubt up till here? Yes,
Sir,
no. Yeah.
add the P active layer, no sir.
Huh.
That should be overlapped on the NMOS transistor, no sir. There we get DRC error, sir. Like when we're trying to put it on the NMOS and PMOS transistors.
No. You don't have to put it. You have to make the connection first like this. Are you looking at here? If you
Yes, sir.
put it directly on this, it doesn't mean that it is connected. It will show the error. It will consider it as two different layer. In this tool I'm talking about. Whereas in the cadence it is connected. It becomes like connected. Whereas in this tool it is not connected until unless you connect it manually like this. What is shown here? Did you look at here? Did you
Yes, sir.
understood?
Yes, sir.
You have to make this connection physically, okay, and then you have to move it so that it is taken near with the minimum DRC role. Any doubt other than that? Yes. If there is no doubt, I'll just stop it here. Okay. Farhan, any doubt? So I'll just check with why it is not dragging up till 5 volt. That is with the problem with the code, I think. Okay. I'll just look into that. But this is a procedure for writing up to do the layout, writing up the spice code for the layout and to simulate this. Is that clear? Yeah. So you can work up till here for the layout part. Okay. And from next lab onwards, you can start doing the layout on this for the digital circuits, what you have done so far. Okay. And along with that, you have to start with the part B analog circuits as well. Is that clear? Okay, then fine. So I'll just stop here. Yes, Shreyas. Shreyas, wait. I just. I'm facing issue in microelectric Ubuntu. If wanted, yeah. If you are ready, you can share it. We will just look into that. What is the problem with that? Shreyas.
Sir, just few minutes, sir. I will show it to you, present and show
Yeah.
it to you.
Yeah, yeah. So I will just stop recording this. I will share the same with you for procedure to work on doing the layout. So I'm waiting for Shreyas to present.
Sir, can I present?
Yeah, share it.
Sir, is it visible?
Yes.
Sir, this is the schematic that I have designed, sir.
Huh.
Uh, the thing is, sir, I have checked everything like DRC and all.
Huh.
I mean, literally, there is no error actually. You
Okay.
can see, you can check it out
Yeah.
here also, sir.
Hmm.
But if I uh, put for
Yes.
Spice
No,
Deck,
no,
sir, I have
no.
even written the code also here.
Okay.
Uh, if I try to write the Spice Deck, sir, it comes like this.
Okay.
When I try to save it, sir, it just simply like becomes standalone, sir. When if I just show, it is showing only running Spice commands and
No,
so
no, no,
on.
no. Then it is you, there is a problem in the setting up in the preference. Go to the preference.
Okay, sir.
Go to the preference window.
You
Go
can.
to tools. First, we'll start with the general. Come from general.
Yeah, sir.
Mm,
You can see, sir. Or,
ಓಕೆ ಜನರಲ್ ಆದ್ಮೇಲೆ ನೆಕ್ಸ್ಟ್
technology, sir.
ಟೂಲ್ಸ್ ಗೋ ಟು ಟೂಲ್ಸ್ ಸ್ಪೈಸ್
sir.
ಸಿಡಿಎಲ್
Sir?
ಸ್ಪೈಸ್ ಸಿಡಿಎಲ್ ಇಲ್ಲಿದೆ ಅಲ್ಲ ಕೆಳಗಡೆ
Sir.
ಸ್ಪೈಸ್ 3
ಸರ್ ಆಕ್ಚುಲಿ ಉಬಂಟುಲಿ ಸ್ವಲ್ಪ ಇದು ಬೇರೆ ತರ ಇದೆ, ಸೊ ಅದಕ್ಕೆ ಹಂಗೆ ಕೊಟ್ಬಿಟ್ಟು ಕೊನೆಗೆ CAD.exe ಅಂತಾನೆ ಸೇವ್ ಮಾಡಿದೀನಿ ಸರ್. ಮತ್ತೆ ನೀವು ಕೊಟ್ಟಿರೋದು ಇದನ್ನ ಹಾಕಿ.
Okay, before that, yes, anyone else? ಹೌದು, ಅದು ಬರೀ exe ತೆಗೆದ್ಬಿಡು ನೋಡು, SCAD3 ಅಷ್ಟೇ ಕೊಟ್ಟು ನೋಡು. Okay,
Okay,
and
sir.
check out what is the argument that you have written in the right side once.
This one, sir.
Tell me.
1 minute, sir.
Okay.
So,
And also check whether the argument field is same in the case of Ubuntu also in the net ones from where you have downloaded this window. I mean this tool.
Sir, I didn't get it.
No, what I mean here, wait a minute. Okay, 1 minute. Shreyas, go to your C drive. I mean, I want you the location of that LT Spice where that SCAD3 is located. Show
Okay,
me
sir.
that.
Sir, here it is, sir.
SCAD3. And what is the location it is?
Sir, location, I go to properties and here it is, sir, like parent folder.
Okay.
Complete till here.
Okay, you just remove only that .exe part and run it once. We will see.
Okay, sir. I'll do it.
By default, ಅದೇನಾದ್ರೂ ತಗೊಳುತ್ತಲ್ಲ.
Sir, I have given only SCAD3.
Okay, run now. Click OK.
Click OK.
Tools, DRC, do DRC.
Okay, sir. Sir, 0 errors, 0 warnings.
Okay, run it. Right space there.
Sir, I just give this as in.
Give it as save. Let it overwrite. It is just in what that
Okay,
log
sir.
file which you used to get this one overlap. Yes. ಮತ್ತೆ ಅದೇ ತರ ಆಗ್ತಾ ಇದೆನಾ?
Sir, like it is showing return. Actually, sir, I have also installed this one LT Spice and also that wine kind of thing that works especially for running Windows related machines. Through this only I installed LT Spice, but you can see here, no, sir. But I don't know why it is not that output is in that graph is not coming, sir. Actually, sir, you had given VSS and all, so it was also asking for small warnings like ground has not connected. So just I connected the ground and ran it, sir. No errors, sir, but the thing is, I don't know.
Execute ಆಗ್ತಾ ಇಲ್ಲ ಅಷ್ಟೇ ಅದು .exe whether
sir.
you have to change that the mode of operation execute ಆಗ್ತಾ ಇಲ್ಲ .exe ಅದು ಆಪ್ಷನ್ಸ್ ನೀವು ಇದನ್ನ ಮಾಡ್ತಿದ್ರಲ್ಲ CHMOD ಪ್ಲಸ್ ದಟ್ ಫೈಲ್ ನೇಮ್ ಏನಿದೆಯಲ್ಲ SCAD .exe ನ
sir.
ಅದನ್ನ ಚೇಂಜ್ ಇದನ್ನ ಮಾಡ್ಬೇಕು ಇನ್ನ ಮೋಡ್ ಅಂತ ಕೇಳ್ತಾ ಇದ್ದೆ. ಐ ಮೀನ್ಸ್ ದಟ್ ಈಸ್ ಇನ್ ದ ಲಿನಕ್ಸ್ ಕಮಾಂಡ್ ಅಲ್ಲಿ.
ಸರ್ ಗೊತ್ತಿಲ್ಲ ಸರ್.
But actually ಏನಂದ್ರೆ Windows .exe files are not compatible with any other desktop operating system, including Linux ಅಲ್ಲೂ ಕೂಡ.
Okay, sir.
Excuse me, sir. Hello.
ಹಾ ಹೇಳ್ಪ.
Sir, Windows ಅಲ್ಲೂ ಲೈಕ್ ಸೇಮ್ ಎರರ್ ಬರ್ತದೆ. ಅವ್ನು ತೋರ್ಸಿದ್ನಲ್ಲ ಅದೇ ತರ.
ವಿಂಡೋಸ್ ಅಲ್ಲಿ ಬಂದಿದ್ರೆ ಅದು ನಿಮ್ದು ಸೆಟ್ಟಿಂಗ್ ಅಲ್ಲಿ ತಪ್ಪಾಗಿದೆ ಅನ್ಸುತ್ತೆ. ಯು ಜಸ್ಟ್ ಶೇರ್ ಇಟ್, ವಿ ವಿಲ್ ಜಸ್ಟ್ ಸಿ